everyone! Welcome to another episode of HALINA'T MATH-TUTO sa Dasmariñas North National High School. I am your teacher-lecturer, Ms. Roselvi Edrosolano. And today, we will discuss about theorems on central angles, arcs, chords, and inscribed angles. You have learned from your previous lesson the definition of central angles, arcs, chords, and inscribed angles. Now, we will learn the first 4 theorems related to these terms. To start, let's have theorem number 1. In a circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding central angles are congruent. To illustrate, let's have the given circle X on the right. Given that angle AXC is congruent to angle BXD. This is angle AXC and this is angle BXD. It is given that angle AXC is congruent to angle BXD. Since the 2 central angles are congruent, the minor arcs they intercept are also congruent. Arc AC is the intercepted arc of angle AXC, and arc BD is the intercepted arc of angle BXD. Hence, arc AC is congruent to arc BD. Arc AC is congruent to arc BD. Now let's try example number 1. Using the same circle X on the right, given that angle AXC is congruent to angle BXD. If the measure of angle AXC is equal to 50 degrees, find the measures of the following: the measure of angle BXD, the measure of arc AC, and the measure of arc BD. Given that the measure of angle AXC is equal to 50 degrees, what will be the measure of angle BXD? The measure of angle BXD is 50 degrees because angle AXC is congruent to angle BXD. Then, what will be the measure of arc AC? The measure of arc AC is also 50 degrees because arc AC is the intercepted arc of angle AXC. Then, what will be the measure of arc BD? The measure of arc BD is also 50 degrees. Because, according to theorem number 1, in a circle or in congruent circles, 2 minor arcs are congruent if and only if their corresponding central angles are also congruent. What if the given are 2 congruent circles? If circle X is congruent to circle Y, and angle AXC is congruent to angle BXD, and congruent to angle EYF in circle Y, then we say that arc AC is congruent to arc BD, which is also congruent to arc EF in circle Y. Let's try example number 2. Using the same circle X and circle Y, if circle X is congruent to circle Y and angle AXC is congruent to angle BXD and congruent to angle EYF in circle Y, then the measure of angle AXC is equal to 35 degrees. Then we have to find the following measures. Again, angle AXC measures 35 degrees. What will be the measure of angle BXD? The measure of angle BXD is also 35 degrees. Then, what also the measure of angle EYF? The measure of angle EYF is also 35 degrees because angle AXC is congruent to angle BXD and congruent to angle EYF in circle Y. Then, what is the measure of arc AC? The measure of arc AC is 35 degrees because arc AC is the intercepted arc of angle AXC. Then, what is the measure of arc BD? The measure of arc BD is also 35 degrees. And what is the measure of arc EF? The measure of arc EF is also 35 degrees. Because arc AC, arc BD, and arc EF are the corresponding arcs of angles AXC, angle BXD, and angle EYF. Then, according to theorem number 1, again, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are also congruent. Then, let's proceed to theorem number 2. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. To illustrate, let's have circle A on the right. In circle A on the right, given that line segment HO and line segment PE. Given that again, line segment HO is congruent to line segment PE. Since the two chords are congruent, we say also that arc HO is congruent to arc PE. Let's see example number 3. In circle A on the right, again, given that line segment HO is congruent to line segment PE, and the measure of HO is equal to 5 centimeters, and the measure of arc PE is equal to 48 degrees. Find the measures of the following: the measure of line segment PE and the measure of arc HO. What will be the measure of line segment PE? That will be 5 centimeters because line segment PE is congruent to line segment HO, which is the measure is 5 centimeters. Then, what is the measure of arc HO? Arc HO measures also 48 degrees, which is congruent to arc PE. Because, according to theorem number 2, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are also congruent. What if two congruent circles are given? Let's have circle A and circle B. If circle A is congruent to circle B, it is given that line segment HO is congruent to line segment PE and congruent to line segment XY in circle B. Then, we say that arc HO is congruent to arc PE and congruent to arc XY in circle B. Now, let's check example number 4. Using the same circles, circle A is congruent to circle B, and line segment HO is congruent to line segment PE and congruent to line segment XY. Then, the measure of HO is equal to 3 centimeters, and the measure of arc HO is equal to 45 degrees. Find the following measures. What will be the measure of line segment PE? The measure of line segment PE is 3 centimeters. And the measure of line segment XY is also 3 centimeters. Because line segment HO, line segment PE, and line segment XY are congruent. Then, what is the measure of arc PE? The measure of arc PE is 45 degrees. And what is the measure of arc XY in circle B? The measure of arc XY is also 45 degrees because the corresponding arcs are also congruent. Again, according to theorem number 2, in a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Now, let's proceed to theorem number 3. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. Using circle P on the right, line segment YW is a diameter, and line segment XZ is a chord. If line segment YW is perpendicular to line segment XZ, then line segment XV is congruent to line segment VZ. And it follows that arc XY is also congruent to arc YZ. Let's have example number 5. Using the same circle P on the right, and given that line segment YW is perpendicular to line segment XZ, then line segment XV is congruent to line segment VZ, and arc XY is congruent to arc YZ. If the measure of line segment XV is equal to 10 centimeters, and the measure of arc XY is equal to 30 degrees, find the measures of the following. What will be the measure of line segment CV? And that will be 10 centimeters, because line segment XV and line segment CV are congruent. Then, what is the measure of arc CY? The measure of arc CY is also 30 degrees. Because, according to theorem number 3, in a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. Now, let's proceed to theorem number 4. Theorem number 4 states that arc addition postulate the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. Given circle C on the right, adjacent arcs are arcs with exactly one point in common. We have here circle C, line segment UC, line segment RC, and line segment EC. And the common point is point R. In circle C, arc UR and arc RE are adjacent arcs, and the common point is point R. The sum of their measures is equal to the measure of arc URE. Now let's have example number 6. To illustrate, in circle C on the right, arc UR and arc RE are adjacent arcs, and the measure of arc UR is 82 degrees, and the measure of arc RE is 74 degrees. Then, we will just add the two arcs. The measure of arc UR is 82 plus the measure of arc RE is 74, which is equal to 156 degrees. And that is theorem number 4. States that arc addition postulate the measure of an arc formed by two adjacent arcs is the sum of the measures of the two arcs. Let's have the summary of theorems numbers 1 to 4. Theorem number 1. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding central angles are congruent. Theorem number 2. In a circle or in congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Theorem number 3. In a circle, a diameter bisects a chord and an arc with the same endpoints if and only if it is perpendicular to the chord. And theorem number 4, which is arc addition postulate, the measure of an arc formed by two adjacent arcs is the sum of the measure of the two arcs. And that will be all for today's episode. Thank you for watching this video. Again, don't forget to like, share, and subscribe in our YouTube channel so you will be always updated with our latest video tutorials in HALINA'T MATH-TUTO.